So, what we're going to start with is we're going to be looking at linear functions. Make sure you guys are taking your notes. These are worth points. We'll have a note, quick check. Not for a little while, but eventually we'll have one. So, I want to know, I'm going to look at these tables, and I want to know, do they represent a linear function? Linear, anybody know what linear means before we talk about it?
So, linear?
You know what linear means? What was that, Zoe?
Yeah.
Linear just means line.
Oh.
Okay, that's got the word line inside of it. That's all linear means. So if I'm talking about linear, I just mean doesn't make a straight line. Myself enough space. Straight line, that's what linear means. So, if I'm going to look at a table, what that means is every time x changes by 1, y changes by the same amount. So if it's a straight line, every time x on my table here, I got my x on the left, y on the right, every time x changes by 1, y is going to change by the same amount. So we're going to look at some of these and see if they are linear or not. So I'm going to start on this first table here on the left, and I'm going to look at my x. And the x part is easy. Does x change by 1 each time?
Yeah.
0, 1, 2, 3, right? This is all by 1. That part's easy. Where it gets a little tougher is for the y's. So I need to see how much the y's are changing by. If I'm going from 25 to 20, how much is that changing by?
5.
But it's going down 5, right? So I'm going to say this changes by minus 5. Okay. What I'm going to do is I'm going to check 20 to 15 now, and I want to see if I get the same thing. If I'm going from 20 to 15, am I changing by minus 5?
Yeah.
Changing by minus 5, right? And then if I go from 15 to 10, not 10, 15 to 10, I'm going down by minus 5. Because this minus 5, minus 5, minus 5, it's the same each time, that means this is linear. It's linear because every time x changes by 1, y changes by minus 5. If, when we go through this, if they don't all change by the same amount, it would not be linear. So we got to keep that in mind. So let's do a couple more tables. And then you guys will try one. So let's start with this table down here. The x part is easy. 0, 1, 2, 3. The x changes by 1. That part's fine. And then where it gets interesting is with the y's. So if I'm going from 4 to 6, how much am I changing by? 2. And because I'm going up 2, I'm going to say plus 2. So I want to make sure I go by plus 2 each time. So from 6 to 8, that's plus 2. From 8 to 10, that's also plus 2. Plus 2, plus 2, plus 2. This is linear. Alright, let's look at this next one. X part's easy, 0, 1, 2, 3. That's fine, plus 1. Y part, I'm going from negative 1 to negative 8, which is
6.
minus 7.
7.
And then I'm going from negative 8 to negative 15, which is also minus 7. Then I'm going from negative 15 to negative 24. That's minus 9. Are these three numbers the same?
Nope.
No. That means it is non-linear. Which non-linear means not linear. So I'm going to say non-linear. Non-linear just means not a straight line. Another way you could say is not linear if you wanted to, or not a line, but the kind of more official math way to say it is non-linear. Alright, I want you guys to do the one in the box. Tell me, is it linear or is it non-linear? So you're going to have to make sure x changes by 1 and make sure y changes by the same number each time. So on your own, on your paper, we'll have somebody help us out. I'll just do it on the board here. give you about 30 more seconds. Finish it off real quick. All right, you guys help me out. Let's start with Richie. Does the x change by 1 each time?
Yeah.
Yeah, that part's easy. All right, that goes by +1. Straighten. If I'm going from 13 to 17, what am I changing by?
4.
Mm-hmm. And I'm going to say +4 because we're going up 4, right? Okay. And then Ellison, if I'm going from 17 to 20, how much am I changing by? And Susie, if I'm going from 20 to 24. Okay. Keith, are all those the same? So what do we call it?
Non-linear.
Nonlinear. So this is nonlinear. Terrible handwriting, but that's okay. Nonlinear. Alright, so what we're going to do for the rest of the lesson is we are going to be looking at linear functions, or we're going to be looking at some lines. But we're going to end up making the lines ourselves. So, they look like story problems, but they're really not. So, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? We're going to represent this relationship using a table. We're actually not going to do an equation today. Excuse me. So you can cross out the equation part if you want. We're just going to do tables, a table, words, and a graph. So we're going to have to come up with a way to represent the number of rectangles, and we're going to compare it to the perimeter. Let's go to the back. Alex, do you remember what perimeter is?
Yes.
What is it?
I don't know.
So you don't know.
It sounds familiar.
Yeah, you've done it before.
Yeah.
Kyle, you remember what perimeter is? Jared, do you remember what it is? Anybody remember what perimeter is?
Isn't it
Inside of
isn't it like so? Like, see how there's 4 rectangles,
Yeah.
but like it's on the outside of all
Yes.
of them.
Perimeter is the outside. You're thinking of area, Richie.
Oh yeah.
Perimeter is just the distance around, or the outside.
You're not done with this side on the
So perimeter is the outside. So what we're going to do is we're going to look at the number of rectangles, and then we're going to see how much distance there is on the outside. And we're going to start with the table. Then we are going to go through and use some words, and then we're going to make a graph. So I'm going to start with when I have one rectangle. When I have one rectangle, I want to figure out what my perimeter is. If I have a rectangle, remember, opposite sides of rectangles are the same. So if this is 6 over here on the left, this is 6 on the right. If it's 1 on the top, it's 1 on the bottom. The perimeter is just the distance around. All I got to do is add them up. 6, 7, 13, 14. When I have one rectangle, my perimeter is 14. Alright, so let's keep going through. When I have 2 rectangles now, I got 2 rectangles in this shape right here, I need to figure out my distance around. And I got to be careful a little bit. Grab my notes paper here. I have to be careful a little bit because perimeter is the distance on the outside. Do I care about this line here in the middle? If I'm looking at the outside? No, it doesn't matter. So I don't even need that. It doesn't matter. All I care about is the outside. So if left is 6, the right is 6. If this little top piece is 1, this bottom piece is 1. If this top piece is 1, this bottom piece is 1. So my perimeter, I just have to add up the outsides. So 6, 7, 8, 14, 15, 16. My perimeter is 16. And then we're going to keep going through. We're going to do it with 3 rectangles this time. So when I have 3 rectangles, let's see, I don't care about these 2 middle pieces because all I care about is the outside for perimeter. So if left is 6, the right is 6. And then if this top is 1, 1, 1, the bottom is 1, 1, 1. Now I can go through and add up my perimeter. 6, 7, 8, 9, 15, 16, 17, 18. When I have 3 rectangles, my perimeter is 18. And one last one, when I have 4 rectangles. If I have 4 rectangles, I need to find my perimeter, so just like before, I don't care about these middle pieces, I just want to know the outside. 6 on the left, 6 on the right. If I have 1, 1, 1, 1 on top, I got 1, 1, 1, 1 on the bottom. And I just need to add them up, just like before. So 6, 7, 8, 9, 10, 16, 17, 18, 19, 20. So we have made a table. We compared the number of rectangles to the perimeter. So we just did, this question asked us to do 3 things. We just did the first one, the table, which is probably the longest one. So after you do the table, it gets a little easier. So we're going to use words next. So I'm going to describe how this is going to change with words. So there's kind of the same thing we do for words. There's like a pattern, I guess. So if I'm going to talk about words, I'm going to talk about where I started and then how much I changed by. So where am I going to start, or where did I start off in this when I had my 1 rectangle? What was my perimeter? 14, right? How much am I changing by each time?
2.
2, right? That's a plus 2, plus 2, plus 2. So for my words, I'm going to say, start at 14. And then I'm going to say, and then plus 2 each time. So I start at 14, and then I plus 2 each time. That's the words I'm going to use to describe this. That's our second thing we did. So we just did words. The last one is a graph. And you're going to give me a second because you guys can just look at your graph. I'm going to have to copy it over so I can look at stuff real quick. And then we're going to graph it, and that'll be it. These are kind of long problems, but we're not going to do very many of them. So copy. Put this here so we can see it. There we go. So we're going to graph this here. So if I'm going to graph this, I'm going to do a couple of things first. So when we have a table like this, remember the x is always your left side. X is always on the left, y is always on the right, always. Unless it's a left and right, then x is always on top, but I think they're all like this today. So x is always on the left, y is always on the right. And we're going to graph this, but before we do that, let's look through this real quick. We're going to write some numbers on here to help us graph it. So let's start with my number of rectangles. I'm going from 1, 2, 3, 4. Can I go, so I'm starting right here in the very middle, right? Can I count 1, 2, 3, 4 if I'm just counting over to the right? Yeah. That part's easy. But if I look at my y's, I'm going all the way up to 20. Remember, positive y is up here. Can I count up to 20 going up like this?
No.
No, we don't have enough space for that. So what we're going to do is we are going to change, we're not really going to change it around. Instead of counting by ones, we're going to count by twos. Which is fine, we can count by twos. We just have to make sure we count by twos each time. So instead of counting up 1, 2, 3, 4, I'm going to count up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Which is fine, as long as I go by the same amount each time. I went by 2 each time, so I'm okay. So instead of counting by ones, we're counting by twos. There we go. So I've got my graph set up. I'm going by x's, I'm just going by ones. But my y's, I'm going by twos. I'm going by 2 each time on my y's, just to make sure I can fit everything on my graph. This will be nice because sometimes we may go up to like 300. We don't want to count up 300 lines. So we're going to make our graph go by like something else, like 10s or 20s. So we've got our graph set up. We just need to actually graph it now. So I'm going to go through. I have my x and my y, and remember they match up left and right. So my x is 1, my y is 14. So I'm going to go over 1 up to 14. I'm going to put my dot. And I'm going to keep going. My next is 2, 16. I'm going to count over from the middle. I'm going to count over 1, 2. Then I'm going to go all the way up to 16. Put my dot. Then I have 3, 18. From the middle, I'm counting over 1, 2, 3. Go all the way up to 18. Put a dot. And then my last one, 4 and then 20. I'm going to start at the middle. Go 1, 2, 3, 4. All the way up to 20. And put my dot. And then we are almost done. We got one last thing. We are graphing linear functions. Linear means line. Is this a line yet? No. They're kind of all in order, but it's not a line yet. So to make it a line, I got to connect my dots. And I'm going to go a little past and put arrows on the end to make it a line. So I'm going to connect my dots, go a little farther, put some arrows. And that's it. When you graph these, they don't have to be really pretty or anything, because you're graphing them by hand. But I'm trying to make it so you can at least read it. Or at least so I can read it. Because I'm not going to lie, sometimes if I look at homeworks and I don't even know what numbers are there, I'm just like, half points.
You have to put the numbers down?
If you go by something other than 1, yes. So I went by 2s here. So I had to go 2, 4, 6, 8, 10, 12. Yeah, I had to write those numbers down. If you go by something else, you don't need to. Or excuse me, if you go by 1, you don't need to. If you go by something else, you do. All right. Is there anybody still copying this down before I move on? All right. We're going to do one more, and then I'm going to give you guys some time to, we might even skip our exit ticket and just start on homework. Just because these are kind of longer problems. They're not super tough. They're just a little longer. So you know what? We're actually going to skip this one. And we are going to go to, we're not going to do this as an in class. We're going to do this together. Well, you guys are going to help me out with it. I guess I'll say it that way. So we're going to represent the relationship between the number of triangles and their perimeter using a table, and we're going to use words and a graph. We're not going to do equation, we're going to do words. Forgot I changed this and I forgot to change everything. So we're going to do table, words, and a graph. So we're going to start with our table. So I'm going to make a table here. My left side is going to be the number of triangles. My right side is going to be the perimeter. Remember, perimeter is the distance around. And we're just going to fill this in. And this one is actually kind of nice because all the numbers are there already. So I'm going to do the first one, and then you guys are going to finish this off. And then we'll come back and talk about it and kind of go through it piece by piece. So I'm going to start off. When I have one triangle, my perimeter is the distance around 3, 7, 10. My perimeter is 10. Next, we're going to go through and see when we have 2 triangles, we're going to count up the perimeter. And then when we do 3 triangles, we're going to count up the perimeter. And then the last one is when we have 4 triangles, we're going to count the perimeter. I want you guys, on your own, fill in the rest of this table. So count up your perimeters, and then fill in the rest of the table. Then we'll work on we'll describe it with words, and then we will graph it, and then we'll call it good. Archie, go. Possibly. I don't remember if they both taken or not. No one is for sure. But if it's not taken, we'll check. So fill out the rest of this table. If you think you're doing okay with these, you can start on like the words part and stuff. Otherwise, we'll go over it in just a minute. Find the perimeter. And the perimeter is the distance around. Yep. Did you finish your table? That's fine. Yeah, we're taking it piece by piece. That's okay. Gave you about another minute to finish off the table. Then we'll then we'll do the thing for words, and then we'll start to graph it. We got 2 triangles. That's what you're at. There you go. The rest of them are okay. All right, let's work on finishing off this table. So Joycelyn, when we have 2 triangles, what's our perimeter?
14.
Okay. 14. Sophia, when we have 3 triangles, what's our perimeter? 2. And Zoe, when we have 4 triangles?
22.
Yep. All right. So we filled out our table here. We are going to do, so there's 3 parts. We just did the table. We're going to do the words part next. And for the words, it's kind of the same pattern. For the words, we say where we start and then say how much we change by. So if I'm going to do this one, Kyle, where do I start when I have 1 triangle?
4.
That's how much we change by, right? But when I have 1 triangle, where am I starting at? We start at 10. So I'm going to say start at 10. start at 10, and then we change by 4 each time. That's a plus 4, plus 4, plus 4. So we're going to say start at 10, and then change by plus 4 each time. Actually, I'm just going to say plus 4 each time, make it a little easier. Start at 10, plus 4 each time. That's all I need for the words. Start at 10, plus 4 each time. So it's kind of the same thing every time. You say where you start and then how much you change by. And then last thing we're going to do is we are going to graph this. So give me a second because I can't just look at the other slide. I got to copy and paste it here real quick. Give me 1 second. Let me just get rid of all this extra stuff. There we go. Alright. So, we need to graph this, but we need to set it up before we do. So, the left side is always x, the right side is always y. If we are going to graph this, my x is going from 1, 2, 3, 4. I can go by ones, that's fine. Well, let's look at y's. I'm going from 10 all the way up to 22. You want to count up 22 lines? No. So let's make our y's change by something else. So we could go by 2's, or it doesn't have to be by 2's. We can go by whatever we want. So 5's or 10's, but it has to be the same thing each time. I think on this one we can go by, you know what, how about 4's? Let's go by 4's. Make it a little different. So I'm going to make each y worth 4. So I'm going to start here at 0, and then 4. What? That's true. I'll show you what that's going to look like. So 4, 8, 12, 16, 20, 24. That's not too bad of a graph. It's not super tall now, which is nice. We don't have to count up very far. But, like Susie said, if I'm going to graph my first one at 110, 10 isn't exactly on here, so we're just going to kind of guess where it is, which is fine. We're graphing these by hand. It's not going to be perfect. So, I'm going to graph 110 for my first point. My x is 1, my y is 10. I'm going to go right 1 and then up to 10. Now, it's not exactly on here, but I know 10 is going to be between 8 and 12, and so I'm going to kind of put it just in the middle. 1, I'm going to say 10 is about right there. Right in the middle. And we're going to kind of do that for the rest of these. My next one is 2, 14. I'm going to go right 2, start in the middle, go right 1, 2. And I'm going to go up to 14, and I don't know where it's at exactly, but I know 14 is going to be somewhere between 12 and 16, right? So I'm going to just put it in the middle. Call it good now. And then 318, same thing. I know I'm going to go right 1, 2, 3. 18 is somewhere just kind of up here between 16 and 20. I'm just going to put that dot. Then my last one, 4 and 22, same thing, right? 1, 2, 3, 4. I'm going to go up to 22, which is somewhere in the middle there. I don't know. It's good enough, though. Yeah, Alex?
I did it by 2.
That's fine. You just count it up more. So, you can actually go by whatever you want within reason. So, we don't want to count up 22, right? Do you want to make each line worth 50? If we were doing this, you think we could go 0, 50 on the first one? No, that wouldn't be good. So, if you went by 2's, great, that's fine. If you go by 4's, that's fine. Anything bigger than like 4's is probably too big, because you're only going up to 22. So I don't want to go up by like 50's or 100's, that's way too big. My graph would be like teeny tiny, it'd be like way down here squished on the bottom. So, you can go by whatever you want within reason. I actually did 4's on this just to show you. what happens when it's not exactly on there. Like 10 wasn't on here, so I wanted to show you. Just kind of but Alex went by 2s. Great. That's great. Some of these you might have to go by bigger numbers. Like for example, if your biggest number is 400, you probably want to go by 50s. Which is fine. Just depends on your numbers. And we are almost done. We have one last thing. Dylan, what's our last thing we have to do? What? Kinda. Do we have a line up here?
Yeah.
But have we made it a line, or do we just have dots? We just have dots. So our very last step, it's not super tough. We just have to make this an actual line. So I'm going to connect my dots like this, and I'm going to go a little past them so I can put arrows on the end to show that it's a line that goes on forever. So I'm going to go a little bit past my dots and make some arrows, and that's it. That's our last step. All right, that's it. What I think I'm going to do is we're going to skip our exit ticket, and I'm going to give you guys time to work on the homework in class. So these are kind of longer problems, so you won't have a lot of homework, which, but I still want to give you time in class to work on them. So give me just a second. I'll put it on Google Classroom. I would get graph paper first, though, before I put it on, just because you're going to have to graph.